Welcome, guys. In the in the earlier session on survival models, we have spent quite a good number of time in terms of understanding the random variable, the random lifetime variable tx, and we have even found out the functions relating to the distribution function fx of t, and even the survival function sx of t. And we also looked at computing the complete lifetime, and we also looked at the current future expected lifetime, and to compute the survival function, which is tpx, we have also used some kind of integral related formulas, and probably looked at the various parametric kind of models trick where we assume that the hazard function follows, let's say, an exponential kind of a model, or the hazard function follows a Weibull model, or we have even looked at the hazard function following either a Gompers law or the Meckham law, or probably some Gompers Meckham kind of family distribution. So all these things clearly say that the survival function or the hazard rate which we wanted to estimate, we made an assumption regarding the underlying we made an assumption regarding the underlying distribution, and based on that we were going ahead in terms of doing the estimation. But here we will initially get kickstarted with the usage of a non-parametric distribution. So whenever I'm using the word non-parametric, the intention is very simple. The hazard function, I don't make any kind of assumption. I have no assumption regarding the underlying distribution for the hazard function or even the survival rate. So the lifetime future distribution, we are estimating without knowing the underlying distribution of the hazard function. So this means that I'm not bothered about the exponential or the Weibull or whatever it is, which is as clear as say that my future lifetime, which is the x, I am not sure what kind of distribution that it is following or that it will follow. So it is also called as a distribution free kind of mechanism. That is what we are looking at when we are using non-parametric kind of models. Now, getting a little bit deeper in that process of non-parametric estimations, we introduce you to a mechanism called sensory. So we introduce you to this mechanism called sensoring. So sensoring is a process, especially with the context of mortality or anything in the actual calculation. Whenever I'm using the word sensoring, it is that any life I started to observe or investigate, any life I am investigating or doing some kind of estimations on mortality rate, right? I cannot, if I cannot measure the lifetime, if I cannot measure the lifetime accurately for whatever is the process I am following, if I am not able to measure the total exact lifetime accurately, then as a part of my investigation process, some sensory mechanism might have been performed. So this means that I am losing out on some data, or I have a loss of data, and because of that I am unable to compute the exact lifetime of a person or entity which we are investigating. We will only know some kind of as an approximate value, or some kind of an interval kind of or some kind of an interval value, but we don't know the exact value we are looking at. So probably it's as good as say, if my intention is to find out, let's say, the exact age of a person. So if I want to find out the exact age of a person, I need to know the date of birth, and I also need to know the date of death. But if I only, let's say, if I only have, let's say, the year of birth, and I don't know the date of birth, then what I'm getting as the age of the person is just an approximation. Similarly, if I if I am not sure of the date of death of a person who has already died, so the age is going to be only an approximate age, but nothing more of an exact age. And that is why we keep saying that our data has got censored, and arriving at some kind of distribution relating to the exact lifetime becomes quite difficulty with this kind of mechanism. So it is in this context we try to bring in the different kinds of definition that are associated with censoring. So here we will talk about the first dimension being the right censoring versus the left censoring. One dimension in which I look at the censoring, the right versus the left. So this means that in the aspect of the right censoring, it means that I don't know the exact lifetime. I cannot compute the exact lifetime because the observation has stopped. I did not go ahead with the observation. Because the observation has ended, so I cannot compute the exact lifetime of a person. So we only know that it will definitely be greater than or equal to some value. Let's say if the life of a person is greater than or equal to some value, then I cannot know the exact value for that particular observation because I stopped observing it. My investigation has ended. That's the reason I cannot find out the exact age of that person. Or probably in some cases, let's say when people surrender their policies. So I cannot find out their lifetime because their policy is no longer there with me. So those are the kind of scenarios where the right censoring is present in the data. Whereas if, let's say, if I don't know the date of birth for the person, or like if my intention is to compute the age and I don't know the date of birth, then there is some kind of left censoring that is present in the data because I am not able to know the initial values. So especially if I am unable to know the initial values and the censoring has happened before the investigation has started, that is where we talk about left censoring being present in the data. And when looking at the combination or probably a superset of these, which is called an interval censoring, we only talk about special cases of it. So we talk about maybe in terms of special cases, we talk about maybe the right and the left. So we are only saying that whatever the investigation we have done, we are saying that it is falling in a particular interval, but we don't know the exact date of birth or even the date of death. So it's only a period. So it might be born in the year 2001 and then this person died in the year 2013. I don't even know the exact date of birth or the exact date of death. That is what we are calling as, or what we are talking of as, an interval based censoring, which means that the right and the left, both of them are typically treated as special cases where in one side is where where one side is only known and the other side is typically not known. So that is where the interval censoring is coming into picture. Now the other dimensions as far as censoring is concerned, we are looking at whether the censoring is random or not. So here when I use the word random, it is like whatever the life I'm observing, that life has left the investigation. So this life has left the investigation, and it's not because of death. So this is not because of death, or it's not because of the risk that we want to assess, but for any other mechanism. So probably I could think of the life who I'm observing for the mortality. They move to a different place, or they have left the hospital, or they have surrendered their policy and their information is normal. It's normal available with me. It means the decrement of that particular life is not because of the risk that we are trying to investigate, but it's because of something else. So, and we also don't know the censoring time, when that particular time is going to leave the investigation, right? Probably when I'm looking at the sickness or death because of sickness, it might so happen that the person who has left the investigation, we don't know, or he could have left because of health improving, or he could have left because of he is not able to find the treatment he has, or he's not able to find the treatment which is sufficiently good enough, and we don't know when that person is going to leave. When all these things are coming into picture, we are building a kind of random sensory into our data. And one more dimension which I look at in terms of the sensory is the informative versus the non-informative sensory. So here we're very clear discussing on whatever life has left the investigation, just by analyzing the lives that have left the investigation, can I conclude something to do with the risk, right? Just by observing the life which have left the observation or left the investigation in the middle, can some kind of information be derived from them? So let's say the parties who have surrendered their policies, if I have to really conclude, so they're all like censored because of the risk which because of the risk which I'm looking at. So the risk can be, let's say, the death. Now, this censoring which has happened, where people have surrendered their policies, if I can derive some extraordinary conclusion about those people who have surrendered, in general, people have surrendered their policies because they feel that their health is really good. So that's the reason why they don't want to continue with their policies, because their health is good. They feel that they're in a good health compared to the people who did not surrender. So this means that just by looking at the censored kind of life, I could make some kind of a conclusion comparing them with the life that are not censored. If at all such kind of conclusions are brought out, then we are saying that that kind of censoring that is present in our data is more of an informative censoring. Whereas in the other cases, where no such kind of information or conclusions we derive, then we're going ahead with a non-informative kind of censoring. So whenever, just by looking at the censored lives, if I can't talk about or conclude, or I can't conclude regarding the future lifetime of those censored lives, then we are calling it as a non-informative kind of censoring itself. So generally, whenever some kind of information or conclusion can be brought out because of the censored lives, we are bringing in the scenario of informative kind of censoring. The other way, or the other dimension of censoring primary, is the definition of the type 1 censoring. So here also look at the type 1 censoring versus the type 2 censoring. Whenever I'm observing a particular set of lives for a predefined time period, right? Well, we know the censoring times in advance. So here the censoring time is known in advance. Censoring time is known in advance. We call it as the type 1 censoring. So here I know the time period uh, where the investigation I'm doing right. So here we're saying for the type 1 censoring, the censoring times are known in advance. So here the censoring time are known in advance, and the time period, when the investigation is going to end. So here we're saying that the type 1 censoring is present in the data. But on the other side, when I'm looking at it's not about the censoring time until a particular number of risks have occurred. If the investigation is done until a number of predefined number of risks are observed, until let's say so predefined number of risks are observed. So let's say we have 50 deaths. So here there's no predefined time period that is present in it, but the investigation is getting ended after n number of deaths that have occurred, or after n number of parties that are that have occurred. So it is in this regard that we typically look at a few survival functions, or probably survival models. So you can well look at the definitions of what we have covered so far, and then you can read about these definitions and get to understand what type of censoring it is. So if we're talking about if it's the right censoring or the left censoring, the random censoring, informative and non-informative censoring, then we also have our type 1 and type 2 censoring. So what I advise you guys is that first just know about these definitions, because you will need to apply them in the survival models. So later on in our next session we will discuss about the survival models. So under the survival models we have what? We have the Kaplan-Meier, and the second one is the Nelson-Allen. So based on these survival models, you need to know about the types of censoring, so in order to answer the questions as well. So a brief assessment or assignment for you guys to do is just read about the types of censoring, then get to understand what each is talking about. So we'll discuss the survival models in the next session. Thank you so much and have a good day.